Welcome to Conspiracist.
Are great to be diving into this.
Today, we're really getting into a fascinating hypothesis. The idea that governments, that they've actively hidden evidence about planetary conspiracy theories.
Yeah, it covers quite a range. Things about the moon, Mars, even planets that might not even exist.
Exactly. And we've got a collection of claims here from various sources. Our goal is really to, explore these claims, look at the reasoning offered, and try to evaluate the evidence objectively.
Absolutely. Sticking to what the sources say and how the arguments are constructed, it's less about belief and more about understanding the structure of these theories.
Okay, so where should we start? The moon seems like a really central point for a lot of this.
Definitely. It's right there.
Yeah.
Visible, visited, makes sense it would attract theories.
One of the more striking ones is this claim that the moon might actually be hollow.
Ah, yes, the ringing moon idea.
Right. It comes from the Apollo missions, specifically when they intentionally crashed parts of the rockets onto the surface, like the Apollo 12 SIVB stage.
And the Apollo 13 stage later on, which was even heavier.
And the claim is that seismometers left on the moon detected vibrations, like a bell ringing, that lasted for a really surprisingly long time. Over an hour for Apollo 12, and even longer, like 3 hours for Apollo 13.
Yeah, the sources suggest this puzzled scientists at the time. The argument is basically that a solid body, especially one made mostly of basalt rock like the moon's surface, shouldn't reverberate like that. Basalt absorbs impacts pretty well.
So the implication is a void, something hollow inside that allowed the waves to bounce around for so long.
That's the interpretation offered by proponents of the theory. However, seismologists who analyze that data have different explanations. They talk about how seismic waves travel differently through the moon's layered structure compared to Earth.
So not necessarily hollow, but maybe just structured differently than we initially assumed.
Exactly. The low seismic attenuation, meaning the waves don't die down quickly, could be due to the moon's internal composition, maybe fracturing deep down, or the way its core and mantle interact. It's complex, but a hollow structure isn't the standard scientific conclusion drawn from that ringing.
Okay, that's interesting. Sticking with Apollo, there's also the issue of the missing tapes, the Apollo 11 telemetry tapes.
Right, the original high-quality recordings of the first moonwalk broadcast.
Yeah, and the argument goes, if the landing was faked, getting rid of the best quality original footage would be, convenient.
And it's true, NASA has acknowledged those specific takes are missing, likely overwritten or lost in archiving shuffle over the decades.
But there's a technical side to this too, isn't there? About the camera they used.
Yes, Apollo 11 used a special slow-scan television camera, SSTV. It wasn't compatible with normal broadcast TV signals directly.
So it needed converting.
Precisely. The signal received on Earth, particularly the really good one, picked up by the Parkes Observatory in Australia, was recorded onto these 1-inch 14-track analog tapes before it was converted for the live global broadcast we all saw. It's those raw SSTV tapes that are missing.
And the converted broadcast tapes still exist?
Yes, and footage from subsequent missions, which used different compatible cameras, also exists. Plus, telemetry data from the scientific instruments left on the moon, the ALSEP packages, some of that still exists too.
So while the loss of the original SSTV tapes is, unfortunate from a historical perspective,
it doesn't automatically mean the whole event was fabricated. There are plausible explanations related to the specific unique technology used on that one mission and, frankly, archiving practices back then.
Okay, let's look at the photos themselves. A really common question is, why aren't there any stars in the pictures taken on the moon?
Right. People think space is full of stars, you should see them.
The argument being, if they were faked in a studio, maybe they just forgot to add the stars.
The explanation usually given involves camera settings and the extreme brightness contrast. The lunar surface, lit by direct, unfiltered sunlight, is incredibly bright.
Much brighter than the stars.
Immensely brighter. So the cameras had to be set with fast shutter speeds and small apertures to properly expose the astronauts, the lander, the landscape. It's like trying to take a picture of stars during the daytime on Earth. The sky is too bright.
So the faint starlight just wouldn't register on the film or the sensor under those conditions.
That's the standard photographing explanation, yeah. The exposure needed for the main subject just washes out faint background objects like stars.
Makes sense. What about the Van Allen belts, the radiation zones around Earth? How did the astronauts get through those without, getting seriously ill?
That's another frequent point. These belts do contain high-energy trapped particles, protons, and electrons from the solar wind captured by Earth's magnetic field. Definitely hazardous.
So the theory is they couldn't have survived the trip.
The counter-argument focuses on two main things: speed and shielding. To get to the moon, the Apollo spacecraft had to travel very fast.
So they didn't spend much time in the belts.
Exactly. Their trajectory took them through the belts relatively quickly, especially the most intense parts. The total dose received was significant, yes, but spread over that short transit time, it was calculated to be within acceptable limits for astronauts. Plus, the spacecraft itself provided a degree of shielding.
So it was a known risk, planned for, and managed through trajectory and spacecraft design.
That's the position. It wasn't ignored. It was a challenge that had to be engineered around.
Okay. One more photo-related point. The shadows. Some analyses point to shadows in different photos, even within the same photo sometimes, that seem to point in slightly different directions or have inconsistent lengths.
Suggesting multiple light sources, like studio lighting, rather than just a single distant sun.
Right. What's the explanation for that?
Primarily the terrain. The moon isn't a perfectly flat billiard table. It has craters, hills, slopes, undulations. An object's shadow will stretch longer down a slope and be shorter going up one.
Ah, so two objects side by side could cast shadows of different lengths just because the ground isn't level beneath them?
Precisely. And apparent direction differences can often be explained by perspective. When you project a 3D scene onto a 2D photograph, parallel lines, like shadows cast by the sun, can appear to converge or diverge depending on the camera angle and the ground contour. You can see similar effects on Earth in photos taken on uneven ground.
So uneven ground and camera perspective can create these seeming anomalies without needing multiple lights.
That's the standard explanation based on optics and the known lunar environment.
Okay, let's shift focus now. Let's go to Mars. The face on Mars is probably the most famous example of potential artificiality there.
Absolutely. That Viking 1 orbiter image from 1976 of the Cydonia region, it really captured the imagination. It does look remarkably like a face in that specific lighting.
Leading to speculation about, ancient Martian civilizations.
Understandably so. But later missions like Mars Global Surveyor, Mars Reconnaissance Orbiter, Mars Express, they took much, much higher resolution images under different lighting conditions. And it resolved into a natural geological formation, a mesa, basically.
Oh, well.
The face was an illusion created by the low resolution, the specific angle of the sun casting shadows that mimicked eyes, a nose, a mouth. A classic case of pareidolia, our tendency to see familiar patterns in random stimuli.
So a trick of light and shadow on a natural landform?
Yep. It's often cited as an example of how initial interpretations, even by scientists sometimes, can be influenced by low-quality data and perhaps a bit of wishful thinking. The sociological aspect is interesting, too, the appeal of finding evidence of past life, especially intelligent life, elsewhere.
It taps into something quite deep, doesn't it? The question of whether we're alone.
Definitely.
Moving beyond specific features, what about whole planets? The Nibiru cataclysm theory comes up a lot.
Nibiru. Or sometimes Planet X. This idea, often linked to interpretations of ancient Sumerian texts, suggests there's a large planet on a long elliptical orbit, maybe 3,600 years, that periodically swings through the inner solar system.
And when it does, disaster for Earth, collisions, gravitational disruption, floods, earthquakes, that kind of thing.
That's the core of the theory. Proponents claim this explains ancient myths and potentially future catastrophes. Some versions even link it to the Anunnaki, supposed extraterrestrial creators of humanity from Sumerian lore.
But from an astronomical standpoint?
Well, astronomers are constantly searching for distant objects in our solar system. There's ongoing research into a hypothetical large planet, often called Planet 9, way out beyond Neptune, to explain some gravitational anomalies in the orbits of Kuiper Belt objects.
But that's not Nibiru.
Not as described in the cataclysm theory. Planet 9, if it exists, is thought to have an orbit that keeps it incredibly far away. Its closest point, the perihelion, would likely be around 200 astronomical units. That's 200 times the Earth-Sun distance. Billions of kilometers away. It poses absolutely no threat of collision or close encounter with Earth. A planet on a 3,600-year orbit that regularly crossed Earth's path would be easily detectable, and its gravitational effects would be obvious in the orbits of other planets. We just don't see any evidence for such an object.
So the astronomical evidence doesn't support the specific Nibiru scenario as popularly described?
Not at all. The interpretation of Sumerian texts is also highly contested by mainstream archaeologists and linguists.
Okay. Another theory that gets discussed, especially online, is Project Bluebeam.
Yes. That one emerged, or at least gained prominence, in the mid-90s. It's quite elaborate.
What's the basic idea?
The allegation is that there's a secret conspiracy, often involving NASA and shadowy New World Order figures, to use advanced technology, specifically large-scale holographic projections, to simulate events like a global alien invasion or the second coming of a religious figure.
Whoa! To what end?
The stated goal, according to the theory, is to cause mass panic and confusion, discredit traditional religions, and ultimately usher in a unified, controlled global society under a single manufactured New Age religion.
That's ambitious. Where does this theory come from?
It's largely traced back to the lectures and writings of one individual, Serge Monist. The actual source material supporting it is described as being quite thin, really stemming from just a few documents attributed to him.
So less based on observable phenomena like the Mars phase or lunar photos, and more on alleged leaked information or insider accounts.
Correct. It's more in the realm of whistleblower-style claims about secret government plots and advanced hidden technologies. Very difficult to verify or falsify, of course.
Right. Okay, one more major category, the hollow Earth theory.
An oldie, but a goodie. The idea that the Earth isn't solid, but actually hollow, maybe with openings at the poles, and potentially even inhabited inside.
It does pop up in mythology and fiction quite a bit.
Absolutely. It has a long history, with various proponents over the centuries suggesting different models, concentric shells, an internal sun, hidden civilizations. Even the hollow moon idea we touched on earlier is sometimes linked.
But what does modern science say? We map the Earth's interior pretty well now, don't we?
We do, primarily using seismology, studying how earthquake waves travel through the planet. These waves behave exactly as expected for a dense, layered, solid and liquid interior. They reflect and refract off boundaries between the crust, mantle, outer core liquid, and inner core solid.
So the seismic data just doesn't fit a hollow model.
Not at all. Plus, you have gravity measurements. Earth's mass, calculated from its gravitational pull on satellites and the moon, corresponds to its size and the densities we know rocks and metals have under immense pressure. A hollow Earth would have much less mass.
And things like Earth's magnetic field.
Generated by the motion of molten iron in the liquid outer core, the geodynamo theory. That requires a specific internal structure, not a void. Geological activity like volcanoes and plate tectonics also points to a dynamic, differentiated interior. There's really no scientific evidence supporting a hollow Earth. All observations indicate a complex, mostly solid sphere.
So scientifically, it's considered disproven.
Thoroughly. But its persistence in popular culture maybe speaks to, our fascination with the unknown hidden worlds, exploration, that kind of human curiosity.
It seems like a common thread through many of these theories, taking an anomaly, a missing piece of data, or even just a suggestive image and weaving a larger narrative around it.
Yes, and often that narrative involves hidden knowledge or deliberate concealment by authorities. It taps into distrust and a desire for alternative explanations, especially for significant or poorly understood events.
And sometimes, as with the face on Mars, it's about how our own perception can initially mislead us when dealing with limited information.
Exactly. Critical thinking becomes really important, questioning assumptions, looking for multiple sources of evidence, understanding the limitations of data.
It's interesting, though, some studies suggest believing conspiracy theories hasn't necessarily increased dramatically over time, despite maybe feeling like it has.
That's a key point from some research, yeah. While specific theories rise and fall in popularity, the overall tendency towards conspiratorial thinking might be more stable than we often assume. It challenges the narrative that we're in some unprecedented age of conspiracy.
And other research links lower critical thinking skills or certain cognitive styles, maybe more intuitive, less analytical, with a higher tendency to endorse these kinds of unsubstantiated beliefs.
Which suggests that education focusing on critical thinking, media literacy, and understanding scientific processes could be crucial. Not necessarily just debunking specific theories, but building the underlying skills to evaluate any claim rationally.
Like understanding why flat Earth ideas persist, even though the evidence against them is overwhelming and quite accessible. It's often rooted in fundamental misunderstandings of basic physics and observation, coupled with the deep distrust of established sources.
Right. And once that disbelief in the official story takes root, people can become much more open to almost any alternative, however unlikely it might seem from the outside.
So, as we've looked at these planetary conspiracy theories, the moon, Mars, Nibiru, blue beam, hollow Earth, the key seems to be applying that objective lens. Looking at the actual evidence cited, the reasoning used, and how it stacks up against established scientific understanding derived from multiple lines of evidence.
Absolutely. It's about critically examining the claims themselves, understanding their origins, and comparing them rigorously to the data we have from decades, sometimes centuries, of scientific investigation.
It's been a fascinating exploration of these alternative interpretations of our place in the cosmos.
Indeed, it highlights the ongoing tension between established knowledge and the enduring appeal of the unexplained or the hidden.
Thanks for listening to Conspiracist.